Hey guys, so we're going to do a quick review, try and make it quick. So we're looking at molecules here, and with a molecule is more than one atom. So you can see here we have two oxygen atoms. They're both in red. So you have one oxygen atom bound to another. So that's called a molecule if you have more than one atom. Water is also known as a molecule. It's also known as a compound because you have more than one element as well as multiple atoms bound together. So you have two hydrogen atoms, these are in blue, and one oxygen atom. So we have our diatomic molecules. This is a term that chemists will use when you have two atoms that are bound together. So you have two hydrogen atoms, two nitrogen, two oxygen. These are typically your nonmetals, and this is how we're going to find these elements in nature. So hydrogen doesn't like to hang out by itself as a single atom, but it likes to hang out as a diatomic molecule, so in a pair. Then we have polyatomic molecules. A common one that you would see in grade 10 is sulfur. Sulfur doesn't like to sit all by itself, so it actually likes to sit in a group of 8. So you're going to see that there are 8 atoms of sulfur all bound together, and that's represented by that subscript here. So if I have S8, this 8 here is what we call a subscript. Okay, and so this 8 down here is a subscript, tells you how many of that element you have. If we were looking at oxygen, oxygen is a diatomic molecule, so it likes to sit in 2. So you have a 2 there. It tells you have 2 atoms of oxygen. Okay. A lot of you during our Google Meet asked about ions. And so an ion is a charged element. And the way an element obtains a charge is if it has gained electrons to make it more negative, or if it has lost electrons to become more positive. I had asked you guys to find the ion charges of these elements, and I did post the key as a Word document just below our notes. But I wanted to show you that for lithium here, Li, its atomic number is 3. So it would have 3 protons to make it positively charged by 3, and then it would have 3 electrons orbiting the nucleus. But that third electron sits in the outer valence, and lithium really just wants to get rid of it. It would rather only have 2 so that its inner ring is full. And so lithium has an affinity to try and look around for other elements that are willing to take this electron off its hands. And so that is how it becomes more positively charged by 1. I've mentioned that everything in the same family or group, these elements all act very similar. They have the same properties. These are all called alkali metals in group number 1 or family number 1. And so you can see lithium has a positive charge by 1 because it gives up 1 electron. Sodium is also going to do the same thing. It's going to want to lose 1 electron, become more positive by 1. Potassium, rubidium, cesium, they will all act the same way. So they all have an affinity to lose 1 electron, and they need to find another element to take that electron off their hands. Elements cannot just lose electrons and release them out into space. They need another element to either accept them or to exchange or to give them electrons. So you'll notice here that these are all metals. You have your alkali metals, alkaline earth metals, and transition metals, and that they're all positive. You can all see aluminum here is 3+, copper is plus or 2+, nickel is 2+, magnesium is 2+, Potassium is plus. So these are all metals, and metals are all losing electrons, okay, if there is an exchange, a chemical reaction occurring. So they're all givers. Metals are all givers of electrons. They want to lose them. You'll notice here that all these nonmetals like fluorine, chlorine, oxygen, and nitrogen, they are all negative. And so nonmetals are very greedy and they like to gain electrons. So nonmetals are going to be gaining electrons while metals are givers and they're willing to lose their electrons and give them up to nonmetals. Okay, going back to our PowerPoint. Okay, so you would have put lithium as plus. Now, one other thing in chemistry, we don't put the number 1. You notice that there's no +1 or -1. Arguably, you could say we're lazy. Like mathematicians, we don't want to put 1. It's redundant. So we just put the plus sign. So make a note that this plus sign does mean +1. Okay, so it's more positively charged by 1. Or over here, more negatively charged by 1. Okay, so for lithium, it should have been +1. Sodium is in the same family, +1. Magnesium is an alkaline earth metal in family number 2. It's 2+. Boron does not have a charge. And then oxygen was 2-. Okay, so I also did post that as a Word document for you guys to check your answers. So again, metals are givers. They like to lose electrons, so they will become more positive. You can argue they're called cations, so cats make you more positive. And then nonmetals are greedy, and so they're going to be gaining all these electrons, and we call them anions. If they are more negatively charged, we call them anions. Polyatomic ions are a group of compounds that hold a charge as a group. So most often when we have a chemical reaction between an element and another element, and we have a compound, that compound, if it's ionic, won't have a charge. You have an exchange of electrons. And so there's no charge to that compound. It's not more negatively charged or more positively charged because there has been a discussion, an arrangement, a deal between these two elements so that one will gain an electron and one will lose, and they will just become neutral. But there's a unique group of compounds that we call polyatomic ions, where as a compound, they actually still hold a charge. So they will be more negatively charged. This group of polyatomic ions, you don't have to memorize them. You'll talk more about them in grade 10. You'll be given a chart or a group or a periodic table that has a section of polyatomic ions to it. Just note that these polyatomic ions are a compound, so they're a group of elements, and they themselves also hold a charge. And they all have special names. You might have heard of some of these names, like sulfate or hydroxide or ammonium. And so they have special names that chemists have already come up with, like cyanide. Okay? So when we look at ionic compounds, we're going to talk about naming ionic compounds this week. That'll be the new lesson. But ionic compounds are always between a metal and a nonmetal. That metal always wants to give electrons, be a giver, and the nonmetal always wants to gain those electrons. It's the taker, it's greedy. And so because of this metal that's in the compound, some of the properties of ionic compounds is that they're good conductors of electricity and that they're solid at room temperature. They also have what we call an ionic bond. And so that is because we have an exchange of electrons. So one element is going to lose an electron and one's going to gain. Again, metals are givers, nonmetals are takers. They're greedy. This is different than a molecular compound, because molecular compounds are between two nonmetals, so between two greedy elements. And between these two greedy elements that both want to gain electrons, you're not going to have an element agree to lose an electron. So they end up coming to an agreement, these two nonmetals. And what they decide is that they will share electrons. They will share electrons so that both of their outer valences, their outer rings, will be full of electrons. And we call this sharing of electrons a covalent bond. So if you ever hear that you have elements that are covalently bound, that means that they're sharing electrons. We also could call it a molecular compound, which makes sense. They're called molecular compounds, and it's a molecular bond. When you have two elements, they are always going to be nonmetals, and they share electrons. Okay? So here you can see a covalent bond. Water is a good example of a molecular compound. Water has two hydrogen atoms. Okay, so they both each have one electron on its outer valence. Both of these atoms are going to want to gain an electron so that they have two on their outer ring. So that would be considered full. And oxygen has 8 electrons. Okay, and so it'll agree to share its electrons with hydrogen in order to be full. And so that's what we call a molecular compound. You'll notice oxygen is a nonmetal, and so is hydrogen. Okay? So this week, we're going to look at naming ionic compounds. During our Google Classroom, I think we will play again. We did this, Google Meet. I did this one of my classes. We played some of these Kahoot games as a review of some compounds and what they are and what they look like. So we could do that. Just a note, this should be a little bit of a review from your textbook readings. But these are some of the properties of metals. Metals are good conductors of heat and electricity, and they're solid at room temperature. Terms like ductile means that you can form them and stretch them into wires. Malleable means that you can reshape them. Nonmetals are poor conductors of electricity, poor conductors of heat, and they're brittle. They're breakable. You can't easily shape them. So they do have different properties. And knowing what are metals and what are nonmetals on your periodic table is very, very important. Metals are going to be everything that's below this invisible staircase here to your left. So everything in group number 1 all the way to group number 13, 12, 13. Aluminum is a metal. It's the only exception that's not what we call a metalloid, which is an element that has both properties of metals and nonmetals. And then all your nonmetals are going to be above this invisible staircase to your right. Okay? So you need to know everything to your left of the staircase. All these guys are metals. They're all going to want to lose electrons. They're all solid at room temperature. They're all good conductors of electricity. And then your nonmetals are everything above the staircase to your right. They all want to gain electrons. They're mostly gases at room temperature. They are not good conductors of heat or electricity. They're very brittle. Again, they're almost always gases. So those are some important things to note. Okay. We'll talk about isotopes a little later, but isotopes are when you have an element that has a different number of neutrons than protons in the nucleus. Okay? And so stay tuned. Our next lesson will be about naming ionic compounds. Okay? Have a great week. Bye.